seems like we are now taking a step forward into the 3D Industrial Revolution, the world of 3D printing. But have you considered, what is 3D printing? How far can we go? First, let's start off by understanding the basic principles of 3D printing. The plastic we are using today is called PLA, which we will explore in depth later.
The filament spool is loaded and secured at the back of the printer. The tip of the plastic is put through the rubber tubing, which leads to the extruder motor. It is then heated to 310 degrees and is liquefied. The printer converts the model of the design into a series of thin cross-sectional layers. The typical layer thickness is around 100 micrometers.
As the photo-hardening polymer is squeezed out of the hot end and deposited onto the plate, it re-solidifies.
Additionally, the printer starts at a particular point called the home position and works out distance relative to the home position. If the position is shifted while it is printing, the object will not have smooth sides. By examining the printer closer, we can see that there are some crucial parts which work together to allow the extruder to move by a precise angle. This is a stepper motor. Inside it, there is a removable rotor. The rotor consists of one permanent magnet and is surrounded by static coils known as stator. When a direct current is passed through a coil, that coil becomes an electromagnet. The charged coil becomes the north pole and attracts the south pole of the magnet, causing the teeth of the rotor to advance by one step. Stepper motors are controlled by activating electromagnets in a particular order. By giving the stator polarity, the stepper motor can spin either clockwise or anti-clockwise. The rotor can therefore make discrete steps.
What is the filament from the 3D printer actually made out of? Lactic acid is made from the fermentation of wheat. This is then converted into polylactic acid through a process called condensation polymerization.
Polymerization is a joining together of short-chained monomers to form long-chained polymers.
This is a molecule of lactic acid. This is then joined together with another molecule of lactic acid, each which have two reactive parts, to form the repeating unit for the polymer, polylactic acid. Polylactic acid is biodegradable because it has ester bonds which can be hydrolyzed. An additional small molecule called water is formed.
One advantage of 3D printing is that intricate objects can be created in one piece. For example, there is no other way of creating an encapsulated dice object without assembling pieces together. The smaller dice on the inside was originally attached to a printed scaffold, which is made out of the same material. The scaffold is then removed manually.
3D printing can be used in everyday life to make objects such as toys, but did you know that 3D printing can also be used for medical purposes? In most cases, after a child is born, cartilage in the trachea keeps the airway open. But in around 1 out of 2,100 live births, a portion of the airway is floppy and collapses, blocking outside air from reaching one or both lungs. A boy was diagnosed with tracheomalacia, the softening of airway structures. Surgical treatments for persistent cases include using a structure inside the airway to prop it open. However, this irritates the trachea. Doctors tried a new procedure where they took a CT scan of the defect. They then used a 3D printer to create a splint for the trachea. The splint itself was printed in layers of a biocompatible plastic called polycaprolactone. The 3D printer heats up a powdered form of the plastic until it melts and can be extruded into a paste. After a few years inside the body, the splint will dissolve, and by that time his bronchus should have grown strong enough to function normally.
3D printing can be of great use to medical laboratories and industries. However, there are many limitations to 3D printing, especially with traditional 3D printing. The most prominent being time. This sundial took 24 hours to print. The T-Rex took 4 times 24 hours. To overcome this limitation, the continuous liquid interface production, also known as liquid 3D printing, can be used. It is 100 times faster than traditional 3D printing, and the objects produced have smooth sides.
It seems like 3D printing has an unlimited potential.
So who knows where 3D printing will take us in the future?